In this video, we will try to understand how the first law is applicable and valid for cycles and processes. So first, for a cycle, let us suppose we have a container filled with liquid. Now let me dip a stirrer inside the liquid. The stirrer is connected to a weight. Then a thermometer is introduced to note any minute changes in the liquid during the experiment. And finally, let us place an insulating material around the container to restrict heat flow in or out of the system. Now, when the weight is lowered, it pulls the string, and as a result, the stirrer starts rotating at a very high velocity. As a result, the temperature of the liquid will increase slightly due to the disturbance caused in the liquid molecules by the stirrer. This is an example of work to heat conversion. Now, if I remove the insulation, the heat that was generated in the liquid will flow out and the temperature of the liquid will again come back to its earlier state. Now, if we draw a plot of this cycle, suppose while going from state 1 to state 2, some amount of work has been done and it got converted to heat. Next, when the insulation was removed, while coming from state 2 to state 1, the system has lost some amount of heat. So mathematically, I can write W produced is proportional to Q. This proportionality can be removed using a constant known as Joule's constant. Okay. Now here in this example, there was only one heat transfer and only one work transfer component. In some cycles, if there are multiple work and heat transfer elements, then we can write that summation of all work transfers is equivalent to the summation of all heat transfers. We can also write that cyclic integral of heat transfers during the cycle is equal to the cyclic integral of all the work transfers. Okay. Next, for a change in state, let us see how we can express the first law. Suppose Q amount of heat is transferred to a system and the system stores some amount of some amount of energy in the form of internal energy, and it does W amount of work. Then mathematically we can express this as Q can be written as Q is equal to del U plus W. Let me simplify this with an example of money balance. Suppose if I am earning 1000 rupees per month and 6000 rupees I am saving in my account, so 4000 rupees will go out of my account as expenses. This is same like this. Okay. Lastly, if there are a number of heat and work components during a process, the first law can be written as a summation of all the components as follows. Please note that when heat flows out of the system, it is considered as negative, and when work is done on the system, it is considered as negative. Okay. So this was all about the first law for cycle and process. Please subscribe MacVidya to get more such informative videos. Thank you.